Hey everybody, welcome to the last part of the 7 segment display lessons here. We're going to be working today on, um, sorry, I had the wrong one open here. We're going to be working today on setting up our 0 through 99 here. Okay, so at this point, again, this is where we left off last week. Really nothing is displaying here, but in our serial monitor, we're counting up to 99. And we're going to do that again in a two-step process where in our pause program, where is it? Our pause program here, we're going to count 2 digits, an X and a Y digit. We're going to count X up until it reaches 9, and then once it goes above 9, then it's going to count up for Y, and once Y goes above 9, it's going to go back to 0 again, and then we're printing out Y and X to give us a composite of this number. So this is not just simply counting X from 0 to 99 and resetting it. This is counting X from 0 to 9, resetting it, and Y 0 to 9, resetting it. Okay, so once we have that done, which you should be done by the time that you're going on to this, if you haven't finished last week's assignment, go back to that. But once we have that done here, we can start to tweak and edit stuff. The first thing we're going to start to tweak and edit is just making 0 through 9 count in our ones column. Okay, so for our ones column to display right now, we want the ones column to be set to be low, and we want our tens column to be set to be high. Okay, but instead of just running like a 0 and everything else here, we need to go through and we need to create a bunch of if statements. Okay, this whole assignment is a lot of if statements. So when we come in here, we're going to say if, and in this case, X is equal to 0. Okay, so what we're doing right now is we are calling upon our pause program to actually start controlling our numbers. Okay, so when X is equal to 0, it's going to perform the 0 function. Then we can say if X is equal to 1, we're now going to do the 1 function here. And we're going to get rid of, at this point, the delay and the reset. Okay, so I'm going to do that for every single one of my X statements. I'm going to say if X is equal to 2 next, I'll display 2, and then I'll move on. All right, so let me do that, and then we'll reconnect. Okay, so here I've finished this up. I've also kind of put comments for this whole thing. If X is equal to 0 through 9, then display that number, okay? So if X is equal to 0, display 0. If X is equal to 1, display 1. If X is equal to 2, 2. All the way down to if X is equal to 9, display 9. If I start my simulation right now, though, all I'm really going to see is this 0. Okay, that's because I'm not actually calling my programs. I'm not resetting things, so I need to edit that, okay? So first of all, this pause program, we're going to move this down to the bottom, right? Because if we go back to our lessons from like a couple weeks ago, we want to call the number, we want to delay, and then we're going to reset. Okay, we're not delaying today, we're going to pause today, but we want to call the number, pause, reset. So when we come back to mine, here I'm going to get rid of this. Okay, so I'm calling my number, that's all of these if X is equal to's, okay? Then I'm going to delay, but in this case it's a pause, okay, because I'm using blink without delay, and then I'm going to reset, something like that. Okay, now when I start my simulation, so now when I start my simulation, you're going to notice that like things are running really slow. Like I just went from 0 to 1 to 2, and you can kind of see like there's these ghosting numbers here because the program, I believe, is lagging. in real life, we probably wouldn't have this same issue, but I think that this program is lagging with how quickly we're jumping in between different functions. So the way to fix this lag problem is to come into our resets, okay? And before we go through the reset command itself, let me stop this. Before we go through the reset command itself, we're just going to slow the reset down a little bit, okay? And we're going to do that with a delay, and we're going to say 5 milliseconds. This is going to slow like our loop time down by 5 milliseconds or so. So that's going to allow our computers to keep up with, I guess, the reset here. To be honest, I'm not 100% sure what's causing this issue, but this does solve the problem. As you can see, we're counting up now. We're counting quickly because my delay is equal, excuse me, my interval is set to be what right now? Interval 200, okay? So we're counting 10 times every 2 seconds right now. Okay, so at this point here, we're only counting our x. You can see here our x is counting up. The two of them align with one another. So now we're ready to start making the y start. Okay, so we're going to stop our simulation. So before we can really determine, we really need to display either the x digit or the y digit, okay, and they're going to be separate from one another. So in order to control what digit we see, we're going to come up top here and we're going to create a new variable, and this new variable is going to be a Boolean. Oh, I'm sorry, I already have this Boolean set up. So we're going to need to use this right here. Boolean digit is set to high, okay? And we say this will be used later to define which digit to send information to. Okay, so that's actually what we're going to be using right now. You probably already have this up here as well, but if you don't, add it. So in our void loop, basically right at the get-go here, we're going to create a line that says digit is set to the inverse of digit. And what this is going to do is this alternates between the ones digit and the tens digit every time through the loop. So this will always be alternating for us. Okay, so I'm going to say if digit is equal to the inverse of the digit. So right now, the first time digit's equal to high, but once we come into here, digit right now is high, so it's going to be the inverse, so it's going to be low. Okay, so because I want, realistically, it doesn't really matter which one I do, but I'm going to say that when digit is equal to low, then my ones is going to be on. So I'm going to say if, okay, so again, another if statement. If digit is equal to, two equal signs, if digit is equal to low, then what I'm going to do here is turn on digit 1, which will be low, turn off digit 10, okay? And then before the pause and reset, those are going to be the last things in this code here. I'm going to close that if statement off, okay? So here I have if my digit is equal to low, then I'm going to display my x information. Okay, now this is where the next part comes in here. Now I'm going to say if digit, okay, and again, I'm below all of my if x statements, okay? So so below all of that, I'm going to say if digit is equal to high, right, because that's the alternate of this low here. If digit is equal to high, then I'm going to display my tens digit. Okay, so how am I going to do that? Well, it's actually pretty easy at this point. Okay, we're going to just take all of our if statements, if x is equal to 0, if x is equal to 1, all that stuff, and I'm going to copy it. And within this if statement, I'm going to paste. Okay, but now instead of saying if x is equal to 0, I'm going to say if y is equal to 0, if y is equal to 1, if y is equal to 2, if y is equal to 3, all the way down through. Okay, so I have if y is equal to 9, right, all the way down. Okay, and again, this if statement starts, so if digit's equal to high, it starts here and it ends down here. Okay, this bracket goes to the 9. After that if statement, I have my pause and I have my reset. Okay, so again, we're going to, first of all, when we come into here, we're going to say, okay, whatever digit is, inverse that digit. Okay, so let's say the digit's high, now digit's going to be low. So if this time through, digit is equal to low, so it's going to go into here. Oh, I forgot this one very important part. Sorry. So we're going to copy this because right now this is turning digit 1 on. Okay, when 1 is low, it allows power to pass through. When we go into our Y, okay, if digit is equal to high, within that statement, we're going to say that our ones digit, this digit here, is going to be high, which is going to turn it off, remember, because that's 5 volts here. We're applying 5 volts to the opposite side, so we have a potential difference of 0 volts, so that'll be off. And we're going to set our tens digit to be low, so when we send 5 volts here, it can pass through all the way to the 10 digit. Okay, and that's going to turn that on. So again, as we go back to the front here, digit alternating between one to the other. If our digit is equal to low, then we're going to turn 1 to low and tens to high, and we're going to display our X digit. Since digit is equal to low, we skip the high stuff. Okay, so we skip all of our Y. We come down below here, we check our pause program. Basically, we're checking our time to see if we should count to the next number. Then we go to our reset program, which we delay for 5 milliseconds just to slow things down a little bit, and we reset the program. Now, because digit is equal to low, the second time through this loop, digit will be equal to high. So we're going to skip our X stuff, and we're going to go straight to our Y stuff, and we're going to start displaying our Y integers. Y is equal to 0, 1, whatever it might be. We're going to come to the end of that, and once again, we're going to check to see if we should advance our counting through the pause program or subroutine, and then we're going to reset everything through the reset subroutine, and then again, it's going to come back, and now since digit's equal to high, it'll be low. It's going to reset the whole process, and in the end, when we start our simulation, we should start counting up, and then our Y digits should start changing as well. Okay, so as you can see here, I'm counting up. Each number is going through. I'm going to count up all the way to 99 here, and then it's going to go back to 0 again. And here we go, 99 and 0, it resets. Okay, so again, let's just talk about what's going on here. For one last time, make sure that you have your variable set up. Make sure you have this digit variable. Set that equal to high to begin with. It doesn't really matter which one you do. Make sure that in your void loop, you start off by alternating between your digits using the inverse sign. Digit is equal to the inverse of digit. Work on your X information. Make sure that your 1 digit is low while your 10 digits high. Display your X stuff. If your digit is equal to high, then you're displaying your 1 stuff. So you're going to digitally write your 1's digit high while your 10's digit is low. You're going to display your Y. After that's done, you're going to run your pause program and your reset program. And make sure in your reset program, before you reset anything, you delay this about 5 milliseconds. You can tweak that. You can see that like if you run it too fast, it's going to slow it down and kind of like bog it up. And if you make your delay too long, then it's going to screw with your pause program. So that will get you guys going with this. Now, before I set you off here for this week, I do want to show you guys, like the debugging operation in this software is the weakest point of it. Okay, so if I hit Control A and Control C to copy everything, I can bring this over to the Arduino IDE to help debug some information. So let me show you guys how to do that quick. Okay, so we are going to run to arduino.cc, And underneath software, we can go to downloads. And there's a web editor up top, which you could probably create like a username, and you could go through that process. You can also download the Arduino IDE. Okay, they have it for Windows, Mac, and Linux. So we're going to get the Windows app, and we're going to say just download. Okay, and that's going to download the app. You can go through and load that. I already have Arduino loaded here. So in Arduino, I'm going to hit Control V to paste everything, to paste my entire assignment. And like, let's just say that I screwed up, I don't know, this. Instead of uploading, we can go to verify, and using this will help us to determine like where we have some issues, right? So it says, well, 0 wasn't declared, okay, and that's because it just got rid of that bracket from somewhere. Right here. Okay, that's because I just got rid of this bracket, so it screwed it all up. So now when I go to verify, it'll help. So this will help debug things. If things come out to be good over here, then you can copy and paste it back again. So for some of you who are getting like a lot of errors, this might help. This also will help because you can go to auto format and like clean your code up, make it a little bit easier to read. And again, we can take all of this, we can copy it, we can bring it back into our circuit itself, and we can paste the code in. Okay, and now when we go to start our simulation, it really shouldn't change anything, but it will make it so that things are a little cleaner. Okay, that's not necessary to do, that's just more an option if you are having some problems debugging your code. So this code is going to be due Thursday night this week, and you can email it to me like you have been. All right, if you have any questions, also email me. Please make sure to get this assignment in on time. Okay, terrific. Thanks so much, guys. Have a great day. Bye-bye.